All right, this video is a continuation of the last one due to an interruption in the building. So you will pick up where I last left off with this part 2, and we'll continue through to the end. All right, we left off saying that this is a no solution system and that no solution systems make parallel lines. If they're parallel lines, that also means that they are inconsistent because they do not touch. So that is the only word that goes along with it other than the fact that they are parallel. Right, if you go to example number 2, we want to take and do elimination to this one, right? And if I take the top one and multiply it by 3, you'll see that I get negative 3x plus 6y equals negative 6. And you'll notice that as soon as you try to do elimination, everything eliminates. That leaves you with 0 equals 0. As soon as you catch on to 0 equals 0, that's infinite solutions. Okay, and in your head, a picture should pop up of what infinite solutions would look like on a graph. Right? And if you recall correctly from your chart on the front, infinite solutions are overlapping lines that touch everywhere. And because they touch everywhere, that means they are definitely consistent. Okay? And because one line depends on the other one to overlap itself, then it is also dependent. Right, for example number 3, you don't have to look too far to see that the y's are going to eliminate. And as soon as you eliminate the y's, your x's are still there. And as soon as you see one of your letters still in the problem, that's an automatic giveaway that you're going to have one solution to this problem. When you tell me that you have one solution, the directions will tell you whether you need to actually find it. 9 times out of 10, you will actually have to find it. So we're going to continue with this problem and get the actual order pair for this system. If you add 2x plus 3x, you get 5x. 7 minus 2 is 5. Divide by 5, you get x equals 1. Okay, go back to one of the original equations, plug in the 1, so I'm going to use the top one, and I'm going to solve it for y. So that's 2 plus y equals 7. Subtract your 2, and you get y equals 5. So when it asks for the actual ordered pair, you do exactly like we've been doing in class, and you come up with the one solution. Now in your mind, you should be thinking about what the description looks like and what the graph looks like. Right? The graph of two equations that get one solution are intersecting lines. And because they're intersecting, that means they touch at least once. And when they touch at least once, that means they're consistent. And because they are two separate lines that only touch in one spot, they are also independent. They are independent lines of each other that just happen to cross at that one point. Dependent means that it's the same line overlapping itself. Independent's two separate lines that cross at one point. All right, so your job for the rest of your homework is to take and complete the try on your own problems at the bottom, these 3. Notice that the directions ask you to determine the number of solutions. So that means in your answer you will have 1, infinite, or none to start off with. Okay. And then if possible, if you say that it has one solution, you then have to find that one solution. All right, so some of them will, some of them won't. If you want to challenge yourself a little further, see if you can determine which ones will be consistent, inconsistent, dependent, and independent. Right, because that is something you're going to have to train yourself to do in class anyway. So if you start now, you'll get better practice with it. Okay, we will do a lot more with this in class, and hopefully the vocabulary will be easier for you to understand and to use on a regular basis.